Welcome to CoJo's Pre-Algebra. All right, here we go. This is a new video. We'll see how you do. So we're going to write down. You got to take notes. And this one can be a little tricky, but it's kind of fun too. So we're going to talk about rational numbers today. So just a quick review, because in class, when you come to class next time, we're going to do homework in class, and you're going to have to classify numbers. So you have to remember what the set of integers are. What are the set of integers? Yes, I hope you said it right. I'm not going to tell you. You're supposed to know. Natural numbers. They're also called counting numbers. And then whole numbers, because there's a whole in the set of whole numbers. 0, 1, 2, 3, 4, etc. Or ellipsis. You got to know how to spell that. All right. So rational numbers. Basically, any number that can be written as a fraction is a rational number. That's the test. So look at these. 0.87, which is 87 hundredths. Da 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 da, ding ding ding. That's a fraction, 87 hundredths. Negative 23. My goodness, how do you write negative 23 as a fraction? Negative 23 over 1. Negative 46 over 2. You can't put 23 over negative 1, though. Remember, the negative has to stay in the numerator or out in front. 2/3, duh, that is a fraction, so we're safe there. Ooh, goodness gracious. This is negative 2.56 repeating. We're going to learn how to do that manually, mathematically today. And 0. Yeah, 0 is a rational number. Last time I checked, 0 over 5 is, yes, that's right, 0. We're not dividing by 0. We want to rewrite 0 as a fraction. So 0 is a rational number. Well, what about this one? How do we tell? Let's forget about the repeating decimal. But this one, 3.76543557, and so on. There's no pattern, so it goes on forever. We can't write that as a fraction because we don't know what to write it over. Here we knew that it was 0.87 or 87 hundredths, so we knew to write 87 over 100. But here we have no clue. So this number is not rational. It's called, what do you think? If it's not rational, yeah, it's irrational. So any number that cannot be written as a fraction is irrational. Very good. Let's go on now. Here we get into the dicey stuff today. Okay, let's go to this repeating decimal. We all know that 0.6, I hope you all know that 0.6 repeating is the decimal 2/3, but we have to prove it. Now, math is wonderful. It allows us to manipulate things to our advantage so that we can do things and make things easier for ourselves. So let me tell you what I'm talking about. So what we're going to do is we're going to set up two equations. Yep. We're going to say that n equals 0.6 repeating. And now we're going to say however many places of the repeating decimal, that's how many, what base 10 number we're going to multiply by. So since we have one digit repeating, we're going to multiply 0.6 repeating by 10. Well, here's something you need to remember always. This is an equation now. You can say, oh, it's a solution, but it's got an equal sign and has a variable. So it's an equation too. It can be a solution or it can be an equation. Right now we're going to call it an equation. N equals 0.6 repeating. So what are we going to do? Only 0.6, only one digit is repeating. So how do we move a decimal place one place? We multiply by 10. Very good. So we're going to multiply whatever we do to one side of the equation, we have to do the other side. So we're going to multiply both sides by 10. Look how I'm doing it. Parentheses. So 10 times n becomes, 10n. And then 0.6 repeating times 10 moves the decimal place one place. So you're going to get 6.666, and we're going to put an ellipsis here to show that goes on forever. Okay, this is equation 1. This is equation 2. We've just created two equations. N equals 0.6 repeating, and 10n equals 6.6 repeating. Now, watch this. We're going to take the second equation and subtract the first equation. Why? Because this is 10 in and that's in. So we're going to write directly underneath this n equals, and we're going to line up the decimal point, 0.666 repeating. And we're going to draw a line, and we're subtracting. So what's 10n minus n? I hope you know it's 9n. Now, see how the 0.6's line up nice and neat? They're gone. Woohoo! All the repeating decimals are gone. And what are we left with? 6. Yeah, we're left with 6. Now, how do we solve for n? Well, if we're doing multiplication and we need to solve for n, we have to undo it. And what's the inverse operation of multiplication? That's right, division. So we divide by 9. Whatever we do to one side of the equation, we must do to the other side. So we divide both sides by 9. This cancels, and we get n equals, well, I hope you don't leave it as 6/9. You always simplify your fractions. Simplifies to 2/3. Wow, we just proved that 0.6 repeating is the is the fraction 2/3. So let's try one that's a little bit more tricky. Now, there's a couple different ways to do this problem. I'm going to show you my problem, okay? My way, and then you can do it my way, or you can multiply by a bigger value of base 10. This one, do you know if it's 0.42 repeating, that means it goes 0.42, 0.42 repeating. How many numbers are repeating? 2. What do we multiply by to move the decimal? We multiply it by however numbers are repeating. The first one, only 6 was repeating. We multiplied by 10, 1 digit. This one has 2 digits repeating, so we're going to multiply by, yes, 100. So I'm not going to do that problem because you're going to do it the same way, except instead of having 10n equals the number, you're going to have 100n equals 42.42, so on, minus n equals 0.42, starting to get the hang of it. But I'm going to concentrate on this one. This one's tricky. So we have n equals 0.5 with only the 4 repeating. So it only has 1 digit repeating. Now here's where you might want to choose to do something different. Me, I like to keep it nice and simple. So I'm going to do 10. And you'll know what I'm talking about when I'm done. So I've only got 1 digit repeating. I'm going to multiply by 10 on both sides. Because I'm manipulating so I can find that fraction mathematically by hand. I want you to understand the process before you just plug it into the calculator. So we get 10n equals, we're going to move it 1 decimal place. Now watch what happens. So we get 5.444 repeating, but we've got to subtract the first equation from the second equation. And look, it's n equals, we got to line up the decimal. Kids get mixed up. It's 0.544, ... Okay, no worries. This is what I like to do. You might want to multiply by 100, but you're still going to have a sticking point somewhere. I like to keep it short, sweet, easy. So the 4's cancel. Look at that. But we can't cancel this. We do subtraction. 54 minus 4 minus 5 is 9. Bring down my decimal, 49. 10n minus n is 9n. Now, no fractions with decimals. So how do we get rid of that decimal? We multiply both sides by what? 10. That's what I like to do. I'm going to multiply both sides by 10. I'm going to get 90n equals 49. Woohoo! Divide both sides by 90. This is just rote. That might take you a while, but we're going to do a lot of these. You'll be able to get it. So when we get that, we get n equals 49 90ths. We can't simplify that, but I guarantee you, if you take a calculator and you say 49 divided by 90, you're going to get 0.544444. Yeah, you will. I promise. Yeah, you don't believe me? Try it. Okay? All right. So now I want you to try these two. So you're going to pause the video, and you're going to do the problems. This one is 0.62 with the 62 repeating. So... and this one is 0.42 with the 2 repeating. So pause the video, and when you're done, start the video again, and we'll go over your problems. Welcome back. I hope you got it right. Let's see how you did. So, did you get, whoa, it always does that. I have always had some kind of mishap. You should have gotten 62/99. You're going to multiply by 100 because the two digits repeat. When I multiply by 100, I get 100 in, 62.6262, and so forth and so on with the ellipsis. I'm going to subtract the original equation, n equals 0.62. These all line up, 0.6262. This one's straightforward. It cancels out. We're left with 62. 100n minus n is 99. And we get, divide both sides, we get 99n equals 62. We divide both sides by 99, and we get 62/99. It doesn't simplify. If it did, you need to simplify. How about this one? I like to multiply by 10. You might have tried 100, but whatever you do, you should have gotten 19/45. So I multiplied by 10. I got 10n equals 4.222. But when I line it up, I have to remember that the n equals 0.4222. So the 2's cancel. They're gone forever. 12 minus 4 is 8. And you bring down your 3. And then we have a decimal. No. Don't like decimals in my fractions. So I'm going to multiply both sides by 10 to move the decimal point. I get 90n equals 38. And then when I do that, I divide both sides by 90, and I simplify 38/90ths to 19/45. That's my fraction. Math is wonderful. We can manipulate any way we want to. I always think it's kind of cool. So, write down 2 things you've learned and 1 question you still have. Write it on an index card or a sticky note. But that's your ticket in with these notes. And in our next class, we will be doing these problems in class. Go back and rewatch the video if you're confused about anything, but it's very straightforward. It's the same process over and over and over again. Have a great day, and I'll see you in class. Bye-bye.